Introduction to Statistics, Chapter 3, Numerically Summarizing Data, Section 3.4, Measures of Position and Outliers. Z-scores. First, we're going to talk about a z-score. A z-score measures the number of standard deviations an observation is above or below the mean. If the data value is larger than the mean, the z-score will be positive. For example, a z-score of 2.15 means the data value is 2.15 standard deviations above the mean. If the data value is smaller than the mean, the z-score will be negative. For example, a z-score of negative 2.15 means the data value is 2.15 standard deviations below the mean. Converting a raw score to a z-score. Z is going to equal the value minus the mean divided by the standard deviation. So the formula for a population would be Z equals X minus mu, which is the population mean, divided by sigma, which is the population standard deviation. An example, if the data set has a mean mu equals 85 and a standard deviation sigma equals 5. Find the z-score for x equals 88 and x equals 75. Well, first, for 88, z would be 88 minus the 85 divided by 5, which is 3/5, which is 0.60. For 75, 75 minus 85 is negative 10, divided by 5 is negative 2.00. Usually z-scores are rounded to 2 decimal places, but be careful, see what your author asks for on the quizzes. Hence, 88 is 0.60 standard deviations above the mean, and 75 is 2 standard deviations below the mean. Now, the formula for a sample. Z would be x minus x bar, which is the mean of a sample, divided by S, which is the standard deviation of a sample. So, again, if a data set has a mean x bar equals 60 and a standard deviation S equals 7, find the z-score for x equals 56 and x equals 75. Well, first, for 56, z is going to be 56 minus the 60 divided by 7, which turns out to be approximately, to 2 decimal places, negative 0.57. And for 75, we take 75 minus 60 divided by 7, we end up with approximately 2.14 when you round it off to 2 decimal places. So, hence, 56 is 0.57 standard deviations below the mean, and 75 is 2.14 standard deviations above the mean. This is what z-scores represent. Now, percentiles. The kth percentile, denoted p sub k, of a set of data is the value such that k% of the observations are less than or equal to the value. Example, the 50th percentile, denoted p sub 50, determines the data value in which 50% of the data values fall below this value. Does this sound familiar? The 50th percentile is another name for the median. Also, p sub 90 means the 90th percentile, and 90% of the data values fall at or below this value, while 10% fall above this value. Find the percentile of a value. StatCrunch will not do this. You will need to use the following formula and a calculator. Percentile of a value equals number of values less than value divided by total number of data values times 100. So, given the following data set, find a percentile of 45. I went ahead and put the data in ascending order to make things easier. So, if I look at this, 19 values less than 45, 24 total data values. Therefore, the percentile of 45 equals 19 divided by 24 times 100, which equals 79.2, or approximately 79, which equals the 79th percentile. Now, using StatCrunch to find percentiles. Load the data in. This time we're going to pick Stat on the top menu, Summary Stats, and select Columns. Under select columns, choose the column you wish to summarize. Under choose only one. Doesn't matter which one. I usually choose N. That way you don't have a lot of extra data in your final answer. Under percentiles, comma separated, enter a value for desired percentile. This will not tell you what percentile a particular number is, but it will give you the number that's at a percentile. Click compute. So now let's go to our StatCrunch. If I had this set of data, it's already in. So now I'd go under Stat, Summary Stats, Columns. Choose my column. I only have one column, variable 1. Under Statistics, I'm just going to choose one. I'll choose N, which tells me how many data values there are. Now down here, under percentiles, this is where I want to enter my percentile. Let's say I wanted the 75th percentile. So I type in 75. Click compute. So the 75th percentile for this set of data would be 56. You notice the data is not in any order. StatCrunch automatically orders it and figures out what the 75th percentile. Now, let me go back under options. Let me edit. Let's say I didn't want the 75th. Let's say I wanted the 90th percentile. I put 90 in under percentiles, click compute. Now it tells me the 90th percentile is 72. So you can find a percentile, but you can't find what percentile a particular value is. Back to our PowerPoint. Now, quartiles. Quartiles are values used to split a set of data values into 4 equal groups. First quartile is the 25th percentile. Second quartile is the 50th percentile, or the median. Third quartile is the 75th percentile. Method for finding quartiles by hand. First, sort the data in increasing order. Find median for the set of data. This is the second quartile. Find median of lower 50% of the data values. This is your first quartile. Find median of upper 50% data values. This will be your third quartile. So, looking at this example, there are 11 numbers in this example, which means there's going to be a number in the middle. So the median is going to be in the middle, and that's at 21. Now, I take the lower 50%. So here's the lower 50%. Now I find the median of this. Well, there's 5 data values, so there is a number in the middle, and that number is 16. So the first quartile is 16. I take the upper 50%, find the median of that. That's 25, so that's your third quartile. So now we have the first quartile, the second quartile, which is the median, and the third quartile. Example 2. Now we have 12 data values. So there isn't a number in the middle. So now what we have to do is find the average of the 2 middle numbers. So I find the average of 36 and 37, which is 36.5. Now, since 36.5 is in the middle of 36 and 37, we take 23 through 36 as the lower 50%. Find the median here, which is the average of 24.25. So that's Q1. And then the upper, we take 37 through 60. So the median would be 48, the average of 46 and 50. So now we have Q1, Q2, Q3 for this set of data. Now using StatCrunch to find quartiles. Load data into StatCrunch. Select Stat in the top menu, Summary Stats, Columns. Select the column you wish to summarize. Now under Statistics, we're going to choose Q1, Median, and Q3. We're going to choose all 3. And click Compute. So let's go to StatCrunch. Looking at our set of data we already have loaded in. I go under Stat, Summary Stats, Columns. Pick my column, variable 1. Now in Stats, I want to get the first quartile, so I scroll down. There's the first quartile. So I click the first quartile. I want the median, So I got to go back up. There's the median. Hold the control key. Hit median. Scroll down. Hit Q3. Now I usually do these in order. You don't need to do them in order because it'll label them in your table. But I just find it easier to do them in order when I look at them. So I click compute. And over here is my table. So Q1 is 35, median was 44.5, Q3 was 56. So it's very quick and easy using StatCrunch to find the quartiles. Back to the PowerPoint. Now, interquartile range. The interquartile range, abbreviated IQR, is the range of the middle 50% of the data values in a set of data. A lot of times we're more concerned about the middle of the data rather than the upper or lower end. So the IQR is just equal to Q3 minus Q1, third quartile minus the first quartile. So looking at our example we had earlier, we had the first quartile was 16, median was 21, third quartile was 25. So the interquartile range would be 25 minus 16, which equals 9. Now, using StatCrunch, you'd load your data, choose stats, summary stats, columns, choose the column, and now this time under stats you would choose IQR, then click compute. So let's look at the example. So our data is already loaded. I would hit stat, summary, columns, choose my variable. Now in my statistics, if I scroll down, right there's IQR. Click IQR, compute. So the interquartile range for this group was 21. Now if you wanted to, I could have, just to show you, I could edit, and I could have chose Q1, held the control key, and Q3. Click compute. Now if I look at my table, I have the interquartile range. Q1 was 35, Q3 was 56. If you take 56 minus 35, you get to 21. All right. Next, we want to talk about outliers. Outliers are data values that tend to be an extreme distance from the other data values. For example, in a given test, everyone scored somewhere from 70 to 98 except for one person who scored 15. 15 would be considered an outlier. Outliers will have a drastic effect on various statistical calculations and should be eliminated before performing statistical calculations. How do we determine if a data value is an outlier? Any data value less than Q1 minus 1.5 times the interquartile range is called the lower fence. So anything below that is an outlier. And or any data value more than Q3 plus 1.5 times the interquartile range is called the upper fence. So anything above this value would be an outlier. An example, if I look at this example, the median would be 78, Q1 is 61, Q3 is 89. The interquartile range would be 28. The lower fence would be Q1 times 1.5 times the IQR, so that's 61 minus 1.5 times 28, which is 61 minus 42, or 19. The upper fence would be Q3 plus 1.5 times the interquartile range. So that's going to turn out to be 131. If we look at our set of data, 5 is below 19, nothing is above 131, therefore 5 is an outlier. And there's only one outlier in this set of data. So if I was going to do any calculation of this set of data, I would probably eliminate the 5 because it is an outlier. This brings us to the end of section 3.4.